Hi there, Andrew Dunkley here. Thanks for joining us. This is Space Nuts, the astronomy and space science podcast, also heard on community radio across Australia, and hello to you too. Coming up in this episode, we will be looking at another James Webb Space Telescope Discovery, and it will blow your mind as to how far back this dates. Space junk has hit home, literally, and life in the solar system beyond Earth could exist if the hydrothermal vents of some of those ocean worlds exist at the right temperature. I think Goldilocks lives there. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here he is again, Professor Fred Watson. Hello, Fred.
Hello, Andrew. You're looking very well, if I may say so.
I need a haircut.
Oh, dear. Okay. Yeah.
I'm booked in tomorrow.
Very good.
Yeah, I usually get it done every 6 weeks. I haven't got much up top, but it sort of foofs out at the sides, and I start looking like some kind of one of the Three Stooges. Which one was it? Larry that had the big,
Yeah, that's
big hair. I get a bit Larry.
There's a paradox because, believe it or not, I get my hair cut every 3 weeks.
Oh,
so
right.
Twice as often as you.
Yeah,
and I've got about 5% of the hair that you've got.
But it's a literal haircut. You get one haircut. I mean, one.
They charge me $25 for it as well. It's an expensive hair.
Yes, I found a backyard business, so I get it nice and cheap.
Done with a lawnmower.
Yeah, pretty much is jump in the hole and done. That explains the ball patch on top.
The ball patch of the yeah.
Oh, these jokes are getting worse.
Terrible. Yeah,
man. Okay, Fred. Let us talk about what is on today's agenda, and we'll start off with this incredible discovery made by the James Webb Space Telescope. Sorry, Geordie.
It's blown Geordie's mind. You can tell.
Sure has. Now, to probably get to the nuts and bolts of the story straight up, this dates back to a time when the universe was only 3% of its current known age. And this is what the James Webb Space Telescope was all about, going back so far that we can almost see the beginning.
Well, that's right. It's we're seeing these objects as they were when the universe was 500 million years old, and that sounds like a lot. But the universe is 13.8 billion years old. So, as you said, it's kind of a few percent of the age of the universe. And look, I'd suggest all our listeners check out this image. It is. I've got it on a press release here from the Webb Telescope, but the headline is Webb captures star clusters in cosmic gems arc. Cosmic gems is the name of an arc of light, which is the result of the gravitational attraction of a huge cluster of galaxies. And so this image, it is just staggering the amount of stuff there is. There's a cluster of galaxies in the foreground. There are tiny, tiny, almost invisible galaxies in the background, which we see distorted because of the gravitational lensing effect of the foreground cluster. So the foreground cluster is called SPT-CLJ0615-5746. Don't forget that.
Already have.
That's the cluster, and it's a cluster that is massive enough that it's distorting the space around it, producing this phenomenon we know as a gravitational lens, and acting as a real magnifying glass for the distant objects behind it, which are distorted, in their appearance because of the gravitational lens isn't like a perfect lens, a glass lens that we use, kind of thing we think of in a pair of spectacles or something like that. It's actually, this is a side note, it's shaped, if you could imagine a gravitational lens converted into glass, it would be very similar to the bottom of a wine glass, the part that sits on the table. That cusp shape of the bottom of a wine glass is a very close approximation. What it does to light is very similar to what a cluster of galaxies does to the light of of whatever's behind it. And you can see when you look through the bottom of a wine glass, it helps if you've taken the wine out first, because otherwise it goes all down your shirt.
I made that mistake last night.
Did you?
Yes.
Well, I've done it before as well, yeah. If you can look through it, you can see that any light source is turned into an arc of light by the refraction of the glass. And that's exactly what the gravitational lens does, only there's no glass involved. All there is the distortion of space, which is just fantastic. So when you look closely at this image of that cluster, whose name I won't bother repeating, you see all these little arcs of light, and there's a couple of them which I think are what are being called the cosmic gems arcs. They're nearly straight lines, actually. And they've got tiny dots of light in them, tiny, tiny points of light. And these have been identified as being due to clusters of stars actually in a distorted galaxy. So you're probably aware, we've talked about it before, Andrew, that the Milky Way galaxy, our own galaxy, has this swarm of what we call globular clusters around it. There's up to about 200 of them. And these are compact star clusters. They're almost spherical. Some of them are slightly flattened, but they've got the name globular cluster. That comes from William Herschel back in the day, because they look like globes, but they're fuzzy and they're made of stars. When you can look through some of the bright ones here in the southern hemisphere through small telescopes or binoculars, and you can see a fuzzy blob. But they are, in reality, hundreds of thousands and sometimes millions of stars. And they're very ancient. We know that these are some of the most ancient stars we can observe. They go back 12, in our galaxy's case, they go back 12, perhaps 12.5 billion years to the days when the galaxy was just a youngster, when the Milky Way galaxy was just a youngster. So what we're seeing now is evidence that those clusters are in existence in some of the first galaxies to have formed. So they must be very, very old objects indeed. They're objects that date from the very earliest period of the universe. And so all the scientists who've worked on this, and actually, principally they're Swedish, in fact. But of course, the James Webb and NASA scientists from the Hubble telescope are also involved. It's a very big collaboration. But they are so excited about this because this gives us a window into studying these clusters. Without the gravitational lensing, you simply would not see them. Without this natural magnifying glass provided by a foreground cluster of galaxies, we wouldn't know that those star clusters belonging to much earlier galaxies, we wouldn't know they were there. Well worth checking out the imagery. It's very easy to find. Webb captures star clusters in cosmic gems arc. Beautiful stuff.
Yeah, quite incredible. The pictures are very, very striking. And you mentioned those cosmic gems. They kind of look like the trail that would be left like by space junk re-entering the Earth's atmosphere.
Yes,
you see bits break off and glow into little blobs, and that's kind of what they look like. But the whole star field effect itself is quite staggering. My question, Fred, is how do they know it dates back to 460 million years into the existence of the universe?
So it's all to do with colours and the spectrum, basically, of these objects. So Webb is equipped with a way of forming the spectrum of very, very faint objects. And you look for, if we're looking at stars, for example, in our own galaxy, you look at the spectrum, you see the light broken up into its rainbow colours. We never detect the colours because we don't need to. All we want to see is that barcode of information that's encapsulated in that. And that barcode of information it is there no matter when the light was emitted. Even if the light was emitted 500 million years after the birth of the universe, it's still got that barcode imprinted on it. And in fact, the scientists in this case look for not so much a barcode as a very obvious feature that we know, whose wavelength at rest we know, and it's redshifted by the expansion of the universe. And by measuring that redshift, how you can determine the age of the universe when this light was emitted. The particular feature they look for is something called the Lyman break. It's in the ultraviolet where this region of the spectrum is, but it's shifted into the infrared because the redshift is so great, because we're looking back so far in time.
Yes. All right. Another question. These images are so very old. What would be there now? They wouldn't exist as we see them now. We're seeing them in history because of the amount of time it takes for that light to reach the James Webb Space Telescope. So what would be there now?
Probably a galaxy, and probably these same star clusters, as we know. Just mentioned that the star clusters in our own galaxy, the globular clusters, have been hallmarked with great age, really since the early days of our understanding of the way stars evolve. We know that these are made of very old stars indeed. As I said, they date back perhaps 12 and a half, maybe even 13 billion years to the formation of our own galaxy. Now, our galaxy is still here, and the globular clusters are still here, and I expect that the particular galaxies that we can see those clusters like a string of pearls, actually, just these dots of light, those clusters, they are they're probably still in existence. There might even be life forms on some of the planets of the stars in those galaxies. Who knows?
Wouldn't that be something? But we have to wait somewhere around 13 billion years for that to be able to see what's happening now, don't we?
Yes, that's correct. Yeah, to see what those galaxies look like now, you've got to wait 13 billion years. That's right.
Yeah. I mean, it's so hard to get your head around that. We're looking at something that was there at almost the dawn of time, and to see it as it is now, we have to wait that time frame again almost.
Yes. Take your time over that. It's going to be a while.
Put it in your diary.
Put it in your diary. Yeah, 13.5 million years. Have another look. I think our own galaxy as it is today, and of course everything in our own galaxy we see, well, maybe a few thousand years ago. When we look at the galactic centre, we're looking back 25,000 years. But nevertheless, that's kind of today by the standards which we're talking about now. And so they may well have evolved into a galaxy very like ours, with all the attributes that we see in our own galaxy.
Yeah, and the other interesting part of this story is without the James Webb Space Telescope, these images couldn't have been taken, couldn't exist.
Correct. That's right. So marvellous piece of kit, doing such a great job.
Yes, indeed. It just keeps giving, doesn't it?
The gift that keeps on giving, that's right.
Yeah, yes. And we're still only really in the early days of its mission, so who knows what we're going to find out next. It is mind-blowing, absolutely mind-blowing. If you'd like to look at that story, you'll find it in plenty of places, but esaweb.org, that's a double B, esaweb.org. Fred, I did mention space junk re-entering our atmosphere and how it looked very much like those cosmic gems. Well, that sort of dovetails beautifully with the next story, which almost turned into a horror story because space junk did re-enter our atmosphere earlier this year and it hit a house in Florida.
Yeah, it did. Went through the roof, apparently. It's in Naples, Florida. A gentleman by the name of Alejandro Otero. He has a seaside home in Naples, and basically March the 8th, something came through his roof and 2 floors of the family home. And very nearly hit his son. So that was, the reason why they got rather miffed about this. Turns out that what it was, and NASA's confirmed this, an almost 3-ton pallet of used batteries, International Space Station batteries, which are, jettisoned from time to time. 3 tons of it, nearly 2.9 tons. And they were jettisoned in March 2 years ago.
My word.
So they...
3 years ago.
I beg your pardon, 3 years ago. Yes, sorry. My
2021.
So. Good. 2021, that's right. 3 years ago. They were jettisoned. They were expected the orbit would be expected to decay over time, and eventually they'd re-enter the atmosphere. They'd partially burn up, but something 2.9 tons. There's enough mass there that it almost certainly would survive re-entry. At least bits of it would, and part of it has now come through the roof, and so. As you might expect, Alejandro is not very impressed with this. And so there is legal action taking place, which involves a claim to perhaps, pay for the damage, pay for the repair of the damage. I'd certainly be thinking along those lines. I'm not sure whether my home insurance policy covers space junk coming through your roof. I know it covers trees coming through your roof because we had one not very long ago that did. In fact, it did little damage to ours, but sadly did more damage to our next door neighbour. It was a tree that had multiple parts to it. So they're covered by our insurance. But if that had been space junk falling on our roof, I don't know what the situation would have been. Now, we do know that under a legal instrument called the Space Liability Convention, which is an international regulation, if the debris had fallen on Canada, for example, or somewhere in South America, then NASA would have been liable for the damage.
Oh, okay.
Because when you put something into orbit, it's the Space Treaty going back to 1967. It's the country that launches that's responsible for it. So it's a national thing. And that sort of made a lot of sense back in the day when there were two countries, two superpowers that had the capability to put stuff into orbit. Things are a lot different now. Anybody with the right equipment can put something into orbit, but it's still the national, the nation that is responsible for that launch that actually has to pay for the damage. But apparently that doesn't work if it falls through the roof of somewhere on your own territory, and so. There's a quick quote from the lawyer who's actually acting on behalf of the Otero family, which is, we've asked NASA not to apply a different standard towards US citizens or residents, but instead to take care of the Oteros, the family, and make them whole. That's a nice way of putting it. So it does set a precedent, this, just to work out how much compensation there should be. And it could turn out to be very expensive. If you're insuring against this sort of thing, that's going to be a very, very costly way of operating spacecraft. You're going to have to build all that into your liabilities.
Cost. Yeah. It really does open up a can of cosmic worms. But going back to the incident itself, NASA was confident, according to what I read, that it would burn up on re-entry completely, and it didn't. So is it a combination of the mass, the speed of re-entry, and the angle of the trajectory that probably stopped it from completely burning up?
I suspect that's correct, Andrew. Re-entry is a fairly well-controlled process, but it does depend on things like the atmospheric pressure, the kind of ambient temperature, which does determine the pressure. A lot of things like that can influence it. We know that, at periods when there's high solar activity, for example, our atmosphere fluffs up. It sort of puffs up a bit like fairy floss. And that means that there's more drag on spacecraft that would normally not be feeling that drag. So maybe if you've got the converse situation where the atmosphere is nice and tight, you don't get the same burn-up effect when you put something through it to burn up. You don't get the same perfect combustion. So really interesting stuff. And re-entry is still kind of a bit of a black art, I think. That's the bottom line.
Yeah, interesting. Of course, lawsuit aside, does insurance cover it? Yes or no? I don't know what the rules are in Australia. You mentioned trees falling, but these days, at least in New South Wales where we live, you have to declare your trees if they're within a certain distance of your house and a certain height.
Okay.
It's actually a question when you apply for insurance. Do you have trees exceeding such a height within 20 metres of your home?
Yep.
And if you don't declare them and it hits the house, I dare say you can't make a claim.
Maybe that is interesting.
In the future, I've had it happen a couple of times when I've changed insurance companies. That's why I chopped all the trees down. No, I didn't. But
yeah,
maybe in the future, the option will be to declare the potential for space junk hitting your house. As rare as that is, you might be able to add it to your insurance.
To your cover, yeah.
Who knows?
Especially if you live in Florida. I mean, you're sort of on the space highway there almost. Although, because this was from the International Space Station, it could have fallen anywhere in the world. It's just bad luck that it hit land rather than sea. Really interesting.
Well, it nearly hit the sea.
Yes, I believe so. That's right. It's just right. It's a seaside house.
Just missed it by that much.
Yeah.
Yes. Well, all things being equal, I'm just so glad nobody was hurt. But yes,
that's right. That's the bottom line.
Certainly a long way to go down the road of this particular lawsuit by the sound of it. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, this story excites me because it talks about life beyond Earth. And this is all to do with something we have talked about before, and you've certainly considered that if we're going to find life elsewhere in our solar system, it might be in the ocean worlds, and particularly if they've got hydrothermal vents. And a new paper has been released suggesting just that.
Correct. And yes, you're right. This is an exciting piece of, it's a kind of theoretical research in a way, although it's based on things that go on our own planet. We're talking about hydrothermal vents. We're talking about an ocean floor and what sometimes are called black smokers, those plumes of super hot water that are emitted from cracks and fissures in the sea floor. And we know that the regions around those vents are very rich in both sort of rich organic chemistry and living organisms. There are, lots and lots of different species that make their home around these warm vents of hot water. And so that's really the thrust of the thinking when it comes to worlds like that, as you mentioned. Europa is one, which we know has a sub-ice ocean with a rocky floor to it. Enceladus is another. Enceladus, of course, we have had a spacecraft, Cassini, which flew through the plumes of ice that were in the South Pole geysers that spurt out ice from that ocean. And my recollection is, and this goes back to probably 2015, 2016 or so, that there was discovered in those ice plumes molecular hydrogen, which I think was seen as a smoking gun, if I can put it that way, for there being hydrothermal vents down at the bottom of Enceladus's ocean. The smokers were there, and hydrogen was being detected as a consequence of that. So there's pretty good evidence that these oceans on the ocean worlds probably do have hydrothermal vents. Now, what has happened recently, and the reason why this is in the news, is a team of scientists at University of California, Santa Cruz, have looked at some of the lower temperature vents, which are very, very common on the Earth's ocean floor, not the ones where it's kind of coming out boiling, which you might think would be a little bit unsupportive of living organisms. The lower temperature ones, where you're talking about water coming out at a fairly benign, perhaps bathwater temperature, they've looked at the science of those. And in particular, they've studied one particular system, which is somewhere near something called the Juan de Fuca Ridge in the northwestern Pacific Ocean. So there is apparently a system of hydrothermal vents there where you've got an extinct volcano, a seamount, down at the bottom of the ocean floor, and water, that's cold, so water goes into that through channels in it, and then it travels underground for about 45 kilometers, and then comes back through another seamount, which is warmer, because the water gets warmer as it flows underneath the ocean's crust. It's quite extraordinary stuff. Okay. We're talking about cavities and passages in the crust of the Earth underneath the ocean. The water comes in, it travels along for this 45 kilometers or so, 30 miles, and then pops up in the seamount where it's got a nice benign temperature. I'm not sure what the temperature is, but it's not boiling hot. It's a sort of, just a reasonable temperature. They call that system, Andrew, a hydrothermal siphon. We all know what a siphon is. It's the way, you can change the pressure to get fluid through. It's a means.
It's how we used to clean the bottom of our swimming pool back in the day before they had pump systems.
It's how I used to drain my petrol tank to patch leaks in the bottom of it when I had an ancient car.
It's also how to steal fuel out of a car.
So that's right. Yes, I haven't done that, but it was always my own that I siphoned out. But yeah, so many of us have had a mouthful of petrol setting up this siphon. Well, this is a lot. This is a lot more benign. A hydrothermal siphon keeps the flow going because heat is being injected by the heat of the rocks themselves. So yes, it's quite an interesting study that they've looked at, and they apparently places where the gravity is very low. And that includes Enceladus, probably includes Europa. Europa is bigger than Enceladus. Enceladus is only about 500 kilometers across. But they found that that low gravity is not an inhibitor for these hydrothermal siphons. And in particular, somewhere like Enceladus, you could have circulation taking place for millions or billions of years, and you might well have this sort of activity taking place long enough for living organisms to kick off. Whatever chemistry is involved in setting up life, they might have a stable environment in one of these planets.
That's amazing.
Or one of these worlds. Yes. So that's. The kind of positive side of the story. There's lots of uncertainties, but it is a very interesting study. The research paper is by A.T. Fisher is the lead author, et al. With several other authors, sustaining hydrothermal circulation with gravity relevant to ocean worlds. It's in the journal Geophysical Research Planets.
It sort of is counter to a story we did a few months ago about a study they did on Titan, and what they found with Titan was, life probably can't exist there, and therefore probably can't exist anywhere in the solar system beyond Earth. So this one sort of counters that.
That's right. Yeah, I can't remember. It was something about what was leaking up through the ice, wasn't it, from the ocean?
Something like that.
I've forgotten the details of it. That's a good point, which did, yes, you're quite right. It did pour cold water on the idea of there being living organisms in the sub-ice ocean of Titan. Titan, of course, another ocean world. And I think it also had relevance to the chemistry on the surface, because it's possible that Titan might have life forms that don't look anything like what we have on Earth that don't use water as their working fluid, but use liquid natural gas, liquid ethane and methane. We were talking about that last time with the seas of Titan perhaps having waves on them. So look, all these studies are they're all trying to build up a picture of what we might expect. And the only way to find out is to go there and start looking in detail. And of course, I think, is it JUICE that's on its way? I think JUICE is the one that's on its way out to Europa. I should check that because there's 2 spacecraft heading in that direction. One's on its way and one's not. And I'm remiss in not knowing which is which. Never mind. Can't know everything.
But around our black smokers in Earth's oceans, there are worms, there are shrimp, there are crabs, there are fish. I dare say we wouldn't expect to find that on ocean worlds beyond our planet, but there could be microscopic life. Who knows? Could be something completely different that we wouldn't even imagine. So it'll be, hopefully one day we'll find out. Won't be tomorrow.
Probably not tomorrow, no, but hopefully within the lifetime of Space Nuts it might.
Yeah. And did you say it was Cassini that went through the plume and picked up all that?
Yes, that's right. Yeah.
They also picked up a note from Goldilocks saying, "Send help, can't bear it."
That's where it came from. I did wonder that.
Possibly so.
I thought it was.
Not sure.
Is that the one with the PS that says, "Where's my porridge"?
Yeah. Yes, exactly. I think we'll leave it there, Fred. Thank you so much. You're ready. But don't forget to chase our episodes on our website, was what I was trying to say, spacenutspodcast.com, spacenuts.io. You can listen to the back catalogue. Some people are still doing that. And don't forget to check out all the other things on our website while you're there. The Astronomy Daily newsletter, you can sign up for that. You can become a supporter of Space Nuts. It's all on our website, so check it out. And if you're a YouTube follower, don't forget to subscribe. Fred, thanks so much. We'll catch you next time.
I hope so. Sounds good. See you soon, Andrew. Take care.
All right. Fred Watson, astronomer at large, and Hugh in the studio, who's not in the studio again. And from me, Andrew Dunkley, thanks for your company. Catch you next time on another edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.